I have a wonderful electronic invention I want you to see.
It looks something like this.
We left the island after creating the stone circle, and today I want to add a new element to it, a small compound wall that follows the elevated area. And to make it easy for myself, I switched the viewport to the top perspective. Of course, I don't want to place each stone individually, so I create a curve that will do the placing for me. That's why I create a new geometry, jump inside, and create the node. The node allows me to create several points, which automatically combine to a single curve. So this here is my start point, and I click away until I end up at the same place. Next I want to change the type of the curve to a NURBS curve and then move the whole thing up. Because right now it's on the 0 plane, so I create a transform and increase the translate. That looks somewhat correct, but I'm sure we have to do some fine-tuning later on when we see the first stones. So these points here at the end are dangling off the border of our island, and we don't want that. So we select our curve node and then we can manipulate each single point one by one. And by the way, please leave some feedback in the comment section about how you find the series so far. What is good, what's not so good, so that I can keep improving my quality for you, my audience. But back to the point. Last but not least, I need to resample the curve. And I want to adjust the length of the segments and the level of detail. So now that I have the guideline for my stone placement, I need the stones. The technique for this next step seems to be a bit more complicated, but Rohan Dalvi does a great job in his workshop in explaining it. I give you the gist of it. I'm going to use the lattice node, and the lattice node will take this box and deform it according to the inputs I give it. The first input will be this box that I turn to polygon mesh, and then I create a copy of this box that is parented to the first box, this time as polygon. Activate divisions, and this is really important. The count of the divisions in this node have to be the same as in the lattice node. And the last input will be a jitter node to create a deformed version of the box. Decrease the scale until you have something that fits your need, and then we can finally create the lattice node. As I said, the lattice node is a bit more complicated because it needs those 3 inputs to work properly. If I hover over the inputs, you can see the description, what they are for. We have the first input, which is for the geometry to deform. The second one is for the rest geometry, and the third for the deformed geometry. And since I already prepared my 3 inputs, I can now just connect the appropriate nodes to the inputs. And when everything is connected, I can now just change the seed of the jitter and get a different result. In this specific case, it's not that important, but maybe you don't want the bottom part of the stone to be that deformed. So how can I exclude points from the deformation? The solution is a little bit of vex coding. The first thing, I want the stone standing on the 0 plane. In this node I will place the coding. But for centering the object on the 0 plane, I once again copy the Y position and paste it as reference divided by 2 to the center. And that allows us to create some coding. And by the way, this is something that absolutely gets me hyped about Houdini. As a software developer by profession, the built-in Vex language gives me so many possibilities to solve complex problems. This one is fairly simple. I only want to deform those points that are above 0 in the y-axis. And I can do that with a simple if condition, which sets the p-scale to 1 whenever that's true. And I use p-scale at this moment because the jitter node can use the p-scale to define how strong the deform should be. And as you can see, all points that are touching the 0 plane are not deformed at all. Then I want to put a smooth node behind this, but only with a very low strength, just enough to get the roughness out of the shape. And I'm pretty sure that I have to shrink this geometry way down, so I create me a transform node that allows me to do that. So I take the scale down a bit, and then I can finally put my stones onto my curve. And like with the druid circle, I once again use the stamp copy. It will allow me to randomize each single stone by using stamp inputs, but for now we only want to get the placement right. We managed to get the stones onto our curve, but as you can see, they are laying flat on the ground and all of them are facing in the same direction. Not quite what we wanted. And the first step to a possible solution is to create a polyframe node. It allows me to define the tangent of the curve and write it straight into the normals. For that to work, I only need to write the capital N into the tangent name. And right off the bat, it seems to work. Only thing left, you could see right here at the front where the curve has a slope, some stones have a weird angle. The reason for that are our normals, but we can solve it by putting one extra vex line into the mix. And this one is really simple, we just need to initialize the normals in the y-axis. And with that, the important part of the placement is done, but we want to add in some randomness into the density of the placement. So I want to create a group that is defined by a random value. For that I can use the Goup Expression. It allows me to write a vex statement which defines what elements are going into that group. I want to decide this for the points, call the group stones, and the expression is called rand at lmnum for the number of the current point plus a random value, and it's supposed to be bigger than a certain value, let's say 0.5. And now that this is set up, we can give the stamp copy the name of the group so that it knows which stones to put out. And now we have a system to put out objects on a curve in a completely randomized fashion, but we are completely able to control this randomization. If I change the additional value for the random function, you can see how the seed is changing. And if I change the condition from 0.5 to a higher or lower value, you can see how I get more or less stones. And keep in mind, this is only one application of this logic. You can apply it anywhere where you want to place objects in a random fashion on a curve. The last thing in our example is only clean up, adjust the size of the stone in comparison to the island, and correct the position of the stones in relation to the Y position, because we want the stones to look as if they are embedded in the ground. And while I finish that up, let me thank you for all that feedback that I got so far. But as I said earlier, if you have any feedback, positive or negative, every feedback helps me to create quality content. Again, I hope you found something useful here, and I'm back next time. If you push that button over there, something great will happen. But I can't tell you what. Just do it.